Okay, let's do a little bit of lens anatomy. I've got two lenses. I got other lenses at school, but I've got two here that are worth going through. So we want to know two things. One is how a lens operates, and then how a camera operates, whether it's a digital camera like this or a video camera. So there's two pieces to try to really understand with the motion capture system: lens and the recording device. All right, so for your lens, you've got a few things that you can use to describe the lens and how the characteristics of the lens. And you can see I have these different rings on the lens. Okay, that's going to change that aspect of it. This ring changes something else, and then I've got another ring back here. Okay, so I've got three rings that change the characteristics of this lens. All right, so this outer ring here, you see it changes just that end of the lens there. That is the focus ring. Okay, that's going to bring the image into focus, so you can take a picture. Yeah, take a picture. That's sophisticated, but that's going to make some finite adjustments to make sure that the image is being focused on the recording device. Okay, and I'll go through that later. This ring here, this middle ring, oh, hold on to the wrong spot there. You can see that's making that aspect of the lens come out further. This is a telephoto lens, and it allows for the focal length of the lens to change. Okay, this is a short focal length. This is a long focal length. That means that the lens, the point that the image will come into focus on the recording device, which is actually going to be back here, is longer. Okay, that focal length is where am I? 300. Okay, this is a shorter focal length of 70 millimeters. Okay, so this is changing the focal length of the lens, and I'll go through focal length in more detail. Focus ring, okay, focus ring. That's for a given focal length. You can bring the image into focus on the recording plane. Focal length will change the actual length of the lens, the focal length of the lens. And that's important, okay, because we're gonna need to know that. So focus ring, focus length. The last ring on this camera is the f-stop or aperture control ring, okay? You see that doesn't make any changes lengthwise to the lens like the other two rings do. But we need to look inside the lens here. And as I change that ring, let me get that. It changes the aperture inside the lens. This changes the amount of light that is being let inside through the lens to the recording device. And this actually has a really big influence on the image. Well, each one of them does, but it has a really unique impact on the lens. In essence, it influences the depth of field that will be in focus for an image. And oddly enough, the smaller the aperture, the less amount of light that comes in. That's not odd. But what's odd is the depth of field of what's in focus is actually greatest for that aperture versus that aperture. Okay. So less depth of field will be in focus when you have the aperture wide open versus very small. And there's numbers on here that we'll go through. That's a aperture of 4. Oops, 4. And this is an aperture of 32. The 4 is bigger than the 32. That's because the diameter of the size of that aperture is 1 over this number. So one fourth is bigger than 1/32. That's smaller, okay? All right, and so when you look at lenses, those are the characteristics that you look at. This lens has a shorter focal length than this lens, okay? Shorter focal length. And again, I'll go through focal length in more detail. And this focal length is 52 millimeters. That one is 70 to 300. Okay, so physically we can see the difference in that. This lens, interestingly, only has a focus ring, and it has a little bit of an adjustment to focal length. It does not allow for control of the aperture on the lens itself, which is odd. Okay, usually there is a focal an aperture control on the lens. This one is digitally controlled by the camera body. All right. And the camera body, in this case, I just have a regular camera, digital camera. What I wanted to show you with this is the recording device, okay? So for each image that's recorded, whether it's a video camera or a still camera like this, uh, the image is coming through the lens and then going to a image capturing surface. Historically, that would be film, 35 millimeter, 110, what have you. But now it's digital and it's a charge coupling device. Okay, now I'll open mine up. Let's see. Okay, that's closed. And I don't know if you can see, there's a mirror in there. Okay, that's a mirror. And what's happening is the image is going in the camera, reflecting upwards and then to another mirror. And then I can see what image is going to be recorded by the lens. So that image from the lens comes in here, does a little funny route up to this opening that I can then view the image, so a viewfinder. But when to record the image, what happens is that mirror lifts up, and that right there, that surface that you're looking at, that is the charge coupling device. That's the sensitive area that is going to record the image, in this case, digitally. All right. If this was a film camera, that charge coupling device would actually just be a piece of film. And that film would then be sensitive to light and record whatever image. There's different settings on the camera to allow the light to come in. Like I said, this camera controls the aperture of this lens. I can't control the aperture. That's controlled by the camera digitally, electronically. But what you can control, something that's really important, is the how long the the mirror is lifted, in essence, or how long the charge coupling device is exposed to light. And that's going to influence how bright or how dark the image is, in part. And you do need to get the setting correctly. In terms of motion capture, if I leave this aperture, if I leave the charge coupling device open to being exposed to light, realize now if there's movement, that charge coupling device will actually record all that as a blur because the image will be moving along. So you want that exposure time typically, and especially in fast movements, to be really small. Well, the smaller that time is that the charge coupling device is exposed to light, the more light you need. And so this is often why we'll put up, when we do 2D work, especially in camera work, we'll put up bright lights to expose the person or whatever object we're interested in to lots of light. And then we can use a short shutter time. We would often say it's a fast camera in order to allow the image to be exposed to light only very briefly. Okay, let me see if I can change that here. Go back to settings. I gotta remember all these settings. Okay, so you can hear that. That's how long the image is being exposed for. Let me go a little bit slower. Okay, that's exposing the charge coupling device to light for a longer period of time. Let me go faster. That's faster, obviously you can hear that. Even faster. And I think that is, how high can I go there? 1/4,000th of a second it's being open for. No, that's not right. But the that's a short time that the charge coupling device is being open for, and this is a long time. Okay, so the camera, along with the lens, works to control how much light will be coming through to the sensitive device, the charge coupling device in this case. The lens has a focal length, and we'll go through more detail why the focal length is important, and an aperture, and then a focus ring as well. A zoom lens has a changeable focal length, but at the end of the day, it has a focal length. So when I take a picture, the focal length is set to whatever this is set to, and it has an aperture and a focus ring. Okay, that's it on anatomy of a camera and lens.